Happy day everyone. Today in this video we are going to talk about the important formulas from the chapter system of particles and rotational motion. If you read all the formulas that we are going to discuss in this video, you will be for sure able to solve any sums asking from this particular chapter. Let's get into the video. So to start about what is center of mass. A center of mass is nothing but a point where whole mass of the system is supposed to be concentrated. So whenever we are saying center of mass, it is nothing but a point where all the masses are acting on. Okay. Now the position of a center of mass depends on two things. That is nothing but one is shape of the body and also size distribution of mass of the body. So whenever we are talking about the position of center of mass, it depends upon shape and size. Okay. Now to talk about the position of center of mass of an object, it will be changing in the translatory motion. Changing in the translatory motion is nothing but the linear motion, but it remains unchanged in the rotatory motion. This is for the position of a center of mass of an object. Now, to calculate the position, velocity and acceleration, we will be using these three formula. To calculate the position of center of mass of the system, we will be using RCM, which is nothing but the position of center of mass. So, it is the sigma of multiplication of m and r. Okay. Then to talk about the velocity, if you take the summation of m into v, that is number of mass given and the velocity respectively, you will be getting the answer, and the same for acceleration. So all these formula is very basics and easy. If you see here in all the formula, m will be remaining constant. Only you have to change r, v and a according to what is asked in the question. Now, to talk about the center of mass of rigid bodies, it is independent of the size. Okay, when we talk about rigid body, it is independent of the state. Now, what is rigid body? A body which have a perfectly defined unchanging shape. Okay, whenever we say rigid body, its shape won't be changed. Okay, it is already defined. So, it is independent of the state. And to talk about its equilibrium, in rotational equilibrium, what we will be using instead of force, it will be torque, right? So summation of external torque will be equal to 0, and translation equilibrium, which is linear, here the external force will also be 0. As you all know, in equilibrium external force is equal to 0, in rotational it will be torque. Okay, now we will talk about the basic equations of the rotational motion. Omega 2 equal to omega 1 plus alpha t, which is nothing but you already know v equal to uat. All the basic three equation which we see in the linear motion, that is the basic equation. Here we will be seeing in terms of the rotational motion. So, and we will be substituting the values accordingly. And theta will be equal to omega 0 plus t plus half plus alpha t square, and omega 2 square will be equal to omega 1 plus 2 alpha into theta. So, for the first, we discussed about center of mass and how it is dependent upon the shape and size, and the basic formula to find the position, velocity and acceleration, and what it will be in the case of rigid body, and also the basic equations of rotational motion.